So we can go to the first biograph actually, and we are going to we see here different types of what we can see in different moments, and on different types of eclipses. In fact, an eclipse is just an occultation. It's a projection effect, and it happens when the moon intersects the field of view of the sun. So actually, it could be a total eclipse, like today in the United States, in the central part of the country. In other areas, it's going to be partial because the moon is not going to hide completely the surface of the sun. And eclipses, in fact, they happen because something that is a curiosity. The sun, although it's much bigger than the moon, covers the projection. The angular projection is essentially the same value. And depending on the relative, since the orbits of the Earth around the sun and the moon around the Earth are not exactly circular, there is small variations on the angular sizes. So sometimes the moon is slightly larger than the sun, so the eclipse is going to be total. And if the moon is slightly farther away, then the eclipse is going to be annular. But in principle, the moon could cross. If we go to the next, actually, I would like to go to here. So this is a representation of how the moon is projecting the shadow, because it's in front, it's in the middle of the path. But in fact, what we are going to see today is this process of occultation, and how the moon is eating step by step part of the solar disk, and the phenomenon lasts actually a significant fraction of time, but the actual total eclipse is only going to be very short, a little bit more than 2 minutes. And as I was saying before, not this one actually, this is a projection effect. In principle, a solar eclipse, it should happen once a month when we have a new moon. But in fact, it doesn't happen because the orbits of the Earth around the sun and the moon around Earth, they are not coplanar. They are not in the same plane. There is a small inclination of around 5 degrees. So only when the moon is in what we call the nodes, is the intersection, the line of intersection between both planes, this phenomenon could take place. So there is a combination of factors, how the orbit is being produced, and also how this shadow is going to be projected on the Earth surface. And this particular case, the Americans are going to be very lucky, because the projection happens to be there. And in other places, it's not very visible, or just barely visible, like in northwest of Spain, just for a few minutes, because this projection effect. So I would like to discuss a few things about why it has been important, and when was the first time an eclipse was recorded. As far as we know, the first record happened to be in Mesopotamia, in what is now Iraq, and there, 4,000 years ago, actually, a little bit more than that, in 2332, before our era, a king of a city called Akkad, Sargon, actually is very important because it was one of the unifiers of one of the big empires that actually shaped the culture, the local civilization. Well, in one of these clay tablets, written in an ancient language and in a very different script, in cuneiform, there is a sentence that actually really describes a solar eclipse that actually happened during a battle. In this area, actually, the people were pretty smart, and they developed the first mathematical computations and a very sophisticated astronomy. And along the years, they developed a theory of how the planets, the sun and the moon were moving on the sky. So they were able to predict, not only to describe what was happening, but also to predict when eclipse was going to happen and where it was going to happen in principle. So lunar eclipses are easy to predict just because they are observable at the same time on the whole planet. Solar eclipses are much more difficult to predict because of this projection factor. Only the total eclipse only happens in a small fraction of the Earth's surface. But as I was saying, these people were able, with different systems, mathematical systems of describing the movement of the moon and the sun, they were able to predict this phenomenon. And here we have one of these clay tablets describing the movement of the moon. As I said, it's quite sophisticated, the mechanism, the theory that is behind. And there is also a representation here of several stars, the moon, and the Pleiades. Actually, these three elements, the Taurus constellation, the Pleiades in Taurus, and the moon, have been very important from the historical perspective. And from that theories, these primitive theories of the Babylonians, has been quite interesting that the moon and the eclipses and the movement of the sun have been very important development of the science, specifically during the 16th, 17th, and 18th centuries. The description of the movement of the moon, that is quite complex, actually. It's not as easy as we can think. There are very subtle points. And how it has been studied has been a key element in what we call the scientific revolution. The first sophisticated description of the moon was carried out by Galileo Galilei in this small book that he published in 1610 when he was using for the first time the telescope. He saw a much more complex moon that he was expecting, with the mountains and shadows, and something that people didn't know at that point. But immediately, even during this century, people were able to get a very accurate description of the moon, and also Galileo at the same time was able to observe the sun. We have to be very careful observing the sun because it has been done properly to protect the eyes. It's something that we have to remember and to remind all the time, that the sun also have spots. So both bodies are not perfect as people believed before them, but they are quite imperfect, let's say. And going back also to these historical records, also in one of the, from my perspective, one of the most important books, most influential books in the history of Western literature is the Odyssey by Homer, or some people like him, because we really don't know who wrote this book. And in this voyage, coming back from after the War of Troy, there are very interesting descriptions of the knowledge at that time, around the 9th century before our era. But there is a mention also of a possible solar eclipse. So it could be the first time that in the West solar eclipse has been described, and some specialists have tried to pinpoint, to determine when this eclipse could have happened, and in principle, it seems that it took place in the year 1178 before our era. So it was one of very interesting facts about this book that we have been able to actually recover a lot of historical information just when people thinking that it was just mythology, and it's not. There are quite interesting science, history, and also astronomy in this book. Going a little bit further, what we know, the first predictions of solar eclipses, there is one possible prediction that was made by Thales of Miletus, but actually it would be at the beginning of the 16th century, but probably this also happened during a battle in Anatolia. But we think now that he didn't predict, he just explained what was going on, what was happening. And the first real prediction, at least in ancient Greece, happened at the beginning of the 4th century by an astronomer that is not very well known, Helicon of Cyzicus. But this thing was recorded just because the philosopher Plato was visiting his city at that time, and this information has been able to reach us. So
perhaps we should switch for a moment to perhaps we should switch for a moment to the team in the United States, because we're about to have the first contact, and then we finish the presentation. Do we have them live, David? No? No live Google Hangout for the first contact? No? And then we continue until we have them.
So then, after the Roman Empire fell, we had what we call the Middle Age, a dark age for science and for knowledge. But it's not actually so dark. Knowledge was still kept in small places, and astronomy was a science that was very important at the time for different reasons. And although some people believed at the time that the moon, the Earth was flat, and the knowledge that was accumulated during the ancient time partially disappeared. There are very interesting books, very interesting studies in that time. Actually, it's this one. Several astronomers. No. This is this one. One British, English astronomer, let's say, that worked in the University of Paris, that it was very important in the 12th, 13th, and 14th century, wrote a very influential book that it was described, it was compiling all the astronomy at that time. He was able to explain again why the moon had phases. And then we have this beautiful diagram here that illustrates his book, and the reason of the eclipses. And as I mentioned before, why it didn't happen every month when we have a new moon. At that time, the instrumentation was quite primitive. This illustration actually gives us a view of how an astronomer in the 16th, 17th century would be able to measure angular distances. The example actually is using the moon to try to locate a point on the planet. And this was another key element for this scientific revolution. What is called the problem of longitude was one of the engines that was key in these advances in the 16th, 17th, and 18th century. And one of the solutions actually was proposed by Hipparchus, an astronomer, a Greek astronomer, in the 12th century before our era, using the eclipses. And actually, he was able to measure the relative position of the two different points on Earth around the Mediterranean basin. And although from the theoretical point of view was a mechanism that it was possible to be used for the determination of positions on the planet, it was very complicated to apply. And since they are not very common eclipses as we see today, actually they cannot be used as often as we would like. The astronomers at that time had to develop other mechanisms, had to improve the theory of how the moon moves around the Earth and how Earth also moves around the sun, to be able to really create a theory, a complete theory, and to be able to really measure positions on the planet.